Hello everyone, hello local AP Abdurrahman, Abdussamad. Hey Abdussamad, nice to see you. Abdullah, Bilin, Brian, Daraja, Joel, Minatullah, Mika, Ricky, Said, Sabah, today. So today we have these two LeetCode. The first one, we're gonna start with search and rotated sorted array, which I believe we did it before, but we can repeat it. And second one is gonna be rotating oranges. So let's jump to it and see what it's gonna be about. Let me take the problem, probably take it to the Excalibur. Okay, and let's take the example and try to understand this there. Okay, so what they're saying is there is an integer array nums. Okay, here is it. What about it? So it's sorted in ascending order with distinct value. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, such that the resulting array okay, the resulting array name k plus 1. Okay, let me try to understand this. Such that the resulting array, okay, so it was before, so for example it was like 1 2 3 4 5, it was like this, and the k number, which is like the pivot index, if for example if the k was 2, it's gonna be pivoted by 2 from the left side. For example 0 1 2 4 5 6 7 might be rotated, pivoted by 3 and become 4 5 6 7. So it should be, so if we pivot this by 2, it's gonna become like this, and 1 2 here. So it's gonna be 3 4 5 1 2. Okay, so the array they give us is sorted, but it's pivoted by some number. For example 4 5 6 7, we can see that it's pivoted by 3. So 0 1 2 4 5 6 7, this is also 3. Okay, I think that part is clear. If someone have a question, please jump in. You can ask in chat or open the mic. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums, or -1 if it is not. Okay, so they're gonna give us a array like this, and it is sorted, but there is a pivot somewhere, and they give us a target. We need to find which index it is. Now, what do you think, guys? Is the problem clear? Who have like a question about problem? Let's see, if we understand problem, then we can go and see what's possible solution we can do with this. I believe we did it with binary search, and I think binary search may be the best optimized solution for this. Any idea? Any idea? So if there's no idea, we can go with the binary search. So binary search gonna be how we can use binary search here. Let's work with this one. So 4, 5, 6, 7. If we did binary search, we're gonna need like 3 pointers. One on the low, one on the high, one on the middle. But how is that gonna work? Because they are not sorted, right? I think binary search work only on sorted array. Do we sort them? Do we sort the array?
Change the indexing.
Yeah, sorted. Just was rotated.
Okay, it is rotated. Now we can see, we can start searching from, so we know, we can see that this part is sorted, this part is also sorted. But rotated. Now if we did binary search, we need to be sorted in all the way, right? So it like what we need to do here. We can start by
Search like usual, but in this case, you just wanna make sure it's how can I say? Whether it's what you're looking for is rotated or not, because not
can you repeat?
just search as usual. You do it as usual, just an extra check.
Okay, so we have target 0. Okay, let's see. 0. The middle here gonna be 7. 7 is not 0. Then we're gonna check if the target is on the left side or the right side, but I don't know because it's rotated.
You have the index in the start. You have the index of the start. So if it's the index of the start or the index on the middle, if it fall in between, it will fall between 4 and 7. No, it doesn't fall between 4 and 7. Does it fall between, let's say, 0 and 2? Yes, it fall in this area. So you have to check.
Okay.
You change the start point.
Okay, I see. So I'm looking for 0. So normally if this was sorted 0, 1, 2, 0, 1, 2, 4.
If it doesn't fall between the start and the middle, then you check the what's after.
So if it was sorted normally, if I check the middle and it was less, I will automatically start checking here, right? This is the normal binary search. If it was bigger, I will automatically start checking here. Now that it is rotated, notice that 0 is less than 7. So normally I need to start checking here, but we can visually see that 0 is here. So it will not work. We can do like Minatala said, is like we're gonna compare this part with this part to see if we're gonna so if we compare this part or this part, we can know that okay. Wait. We compare this part.
I think an idea.
Can you repeat?
I think I have an idea.
Yes, please go ahead.
Okay, what we can do is we should use this 3 pointer that you have already indicated. Now what we do is we have the value, which is our target. They gave us target as 0, right? So we can just measure, calculate if 4 less than 0, we are going to move, since 4 is the left pointer, we are going to be moving in the right direction. So if it is not equal to 0, we move in the right direction, and the same thing for the right pointer.
But you
If
can
it's not
repeat,
equal,
if the middle does not equal 0, what we're gonna do?
okay, let me start again. Now we use the left pointer, for example, which is our target. Our target is 0, right? Now we check the left.
Left
If
pointer
it is
here.
equal to 0, yes. If it is not equal to 0, we move rightwards.
We move this right here.
Yes. Then if our right pointer is not equal to 0, we
This one.
move leftwards. Yes.
We move this right here.
No, the right pointer.
We move this here.
Yes. Then we do the same thing for our middle pointer. If it is not equal to 0, we either move leftward or rightward, depending on which one is bigger or lesser. I don't know if you get it. Then from there, now equal to 0, we have gotten our answer in just 3 steps. Do you get the
Okay, so the binary, this is not binary search, right?
Yeah, I don't think it's binary.
So we're gonna check this, and then if it's not, we're gonna move it to next. Then check this. If it's not, move it to next. Then check this. Then move it to here. But at some point, this gonna check 7 again.
So which means you are going to stop at the middle probably.
You mean left's gonna be here?
Yeah, like the end point. Like once we find our value, we terminate the loop. I don't know if that makes sense.
Yeah, but like imagine it is like a long array, big array. Now, if this move here, this move here. Okay, so this move here. Now this is not the correct value, so it's gonna move here. And then let's say this is not correct value, this gonna move here. This is not correct value, this gonna move here. So like 3 pointer checking from different direction.
Yes. So since the requirement.
And what if at some point the let's say this is checking here, it's not here, and then gonna check here, it's not here. So yeah, I can see how this will work. It's gonna be 3 pointer that's moving on each part. It's gonna just be weird. That's how we're gonna move the middle. But is this gonna be what time complexity? I think is this gonna be?
This should be n log.
Oh, what?
I think this is going to be log n. Log n.
Yeah, I think it can be log n because we are splitting the search.
Yes.
Okay, but we are not taking advantage of sorted, so we can optimize this more, because if we did this, we are not taking advantage of the sorted, because we know a part is sorted, so we can ignore a part. We can ignore this part if we know that this part is sorted. We can compare here. If it's not here, we can go to this side, then ignore this part completely. So this way, this one is going to be more optimized like this.
Yeah, it makes sense. Yeah, it makes sense. Except what if our middle point, our middle pointer is at 6 instead? Like, yeah, it's at 6.
Middle point what?
Yeah, let's assume it is at 6 instead of 7.
Okay,
Let's
let's
assume
let's
it-
remove 7. Let's say there is 6 elements.
No, let's say there's 7 there,
But
but there
but
we have
but the middle gonna
no
be in
let
the middle.
no okay. I'm trying to like think about possible scenario. For example, we have 0, 1, 2, and 3. There's 3 after 2.
Okay,
Now
so
our
we remove
middle is
7.
going.
Or like we
No,
do 3 here.
yes.
Okay. So there
Then
is 4 in, so the middle is still 7.
okay. Okay, I'm looking at the situation whereby the middle is not at 7 but at 6.
Okay, if we remove this, it's gonna be not. So we remove this from here and we do 7 here. Is that good?
Okay.
So 4, 5, 6, 7, 1, 2. So 4, 5, 6, 7, 1, 2. And the middle here is gonna be 6, right?
Yes.
And low and high.
Yeah.
So we're gonna check the left. Is left less than the middle? Yes, it is less than the middle. Then we're gonna start checking here, right?
Yes.
But when we're gonna check here, we're gonna compare is the target is between 4 and 6. For example, we're looking for 7. If we're looking for 7, it's not between these two numbers. Then what we're gonna do is we're gonna move this low to here, and then we're gonna calculate new middle. And if it was between this side, then we're gonna move the height to here, and then we calculate more new middle. You know what I mean?
Yeah, I get you.
So it's still binary
Yes, I get.
search, but by knowing it's just like to know which is the part that's sorted, because let's say we did this was 0, right? And we were like is 4 less than 0? It not. What that mean? That mean this, the right side is sorted, so 1, 2, 3, because it's sorted, right? So it is 4, this is gonna be 1, 0, 1, 2, 3. So if we start from here, we said like check the left, is it less than the middle? If it is, I know this part is sorted. If it's not sorted. Let's see, 4, 5, 0, yes, it's not sorted. So I understand that sorting starts from this side, right? Then I will just jump here and compare if target exists here. If not, I understand it exists here, on the right side and left side. Okay, let's do an example. So here we said we have 4, 5, and then we have 0, 1, 2. Yeah, okay, so this is example, and we have a low pointer, a high pointer in the middle, which can be on 0. Okay, so as a binary search, it start like check if the middle is the target. Our target, let's say our target is gonna be here, so target is 3, which doesn't exist in this area. Now our target is gonna be 0, middle gonna be 0. We're gonna check, is the middle equal the target? No. Okay, so let's start with checking. Now I need to search either this side or this side, and I don't know where is the pivot happen, so I can't see which part is sorted. what I'm gonna do is I'm gonna check, is the low less than the middle? If 4 is less than 0, oh sorry, less than 0. If 4 is less than 0, what that mean? That mean this part right here is sorted, but in our case it's not sorted. That means this is false. So we understand that the from middle to low is not sorted. That means this part is sorted, which is actually is 0, 1, 2. Now it could be like this is 1 and this is 0, and this part is sorted too, but we just wanna like half of it to start. We don't care if it is the beginning of sorting, right? Maybe the sorting starts here, 0, 1, 2, 3, but we just wanna start from somewhere and compare. Now we did this, we know that this part is not sorted. Now we're gonna search here looking for 3, right? So what we're gonna do when this is false, we're gonna move the low. We're gonna say, hey, forget this part, let's go search here. I'm not gonna put it on 0 because we did check 0 case in the beginning. So I'm gonna put it on the next element, which is 1, and now 2 are gonna stay there. And I'm gonna calculate the middle again. The middle gonna be on 1. And I'm gonna check if the middle equal 3, it's not equal 3. If the middle not equal 3, I need to do what?
As 1.
Wait, maybe I did skip something. So we did, it was here, we did move this here. And then we middle is not equal target, so I need again to check if the left no. If the left is less than the middle. Okay, I forgot. What we're gonna do here? I think we're gonna do the same thing we did before, right? We're gonna see. I'm thinking. Okay, let's maybe go back one more time. So we were here, we checked the middle. We said, okay, it's 3. This is not equal 3. We compare this. We said, is this low is less than 0? It's not. Then we move this here. Then we calculate the middle again. The middle here 1. It's not. Which mean I need to calculate. Do I need to search in the right side? Okay, this case make it a bit weird because there's only 2 numbers here, which mean it's gonna be probably the last loop. Okay, but we go with it. So we're gonna say, is the left, the same thing we did, is the left is less than the middle or equal? I guess we're gonna do equal. Is the left is less or equal the middle? If it is yes, we're gonna check if the target exists on the right side. So we're gonna compare if the target is between 1 and 2. It's gonna be false. It doesn't exist on the right side. So we're gonna do mid plus. So we're gonna change. So it means it is in the left side, right? So we're gonna change the. We're gonna change the right. Yeah. So if it is in the left side, that means we're gonna change the right pointer to middle -1. which gonna break the loop, right? The while loop of binary search. When these two pointer cross each other, it stop the loop, which means there is no tree here, which is that's what we want. There's no tree. But let's create another example because that will be confusing someone. So let's make this bigger and put maybe 3 here and even 4, and we have 4 here. I guess we can put this 5 and this 6. Okay, let's start again. Now I believe it's gonna make it more clear. Maybe I write also pseudocode so you can like stay focused, because I do get lost. So first we say we define 3 pointers, low, or like let's call them left, middle, high, or right. Okay, here are them. We define them. We put this in the first element of array. This is the last element, and the middle we got the length, split it on 2, and that's this the index where we put the length. Here is 1 3 3 6 6 7 7 split on 2 is what, 3 3 5. That's 5. It's gonna be 3. So the middle gonna be on 3, which is you know that part is sorted. I think I misread in that one. Okay, so we said we check is the middle. How many elements we have here? 7. It's 7. 7 split on 2. Is it 3? 3.5. It's gonna be 4. Index 4. Oh, so it is gonna be 3. So the index 3 is 1. So 0 1 2 3. So 7 on 2 is 3.5. So the index is gonna be 3, which is 1 0 1 2 3. Okay, so let's keep going. Now this is a good example because we're gonna see that sorting starts from here, but we're still gonna search from here. Okay, let's check the middle. Check the middle if it's equal targets, right? Check if a middle equal targets. Let's say our target is 3. This one. Okay, we did check our target. Now this gonna be inside the while loop. While loop, which loop until left is less, or like loop while loop is like left less or equal right. So as long this left it didn't cross right, or as long this right didn't cross left, it will keep looping. And inside loop we're gonna check if the middle equal target. Target is 3. Okay, now middle is not equal target, so what I'm gonna do is we're gonna compare. We wanna look if this part is sorted, because if this part is sorted I can start from it. If it's not sorted, I'm gonna go to this side, which means this part is sorted. And let's see how we can see if this is sorted. We're gonna check if 5 less than 1. So check if left is equal or less than the number middle. Left number equal or right from middle number. Okay, if this less than the middle number, I understand that it's sorted. Then I'm gonna go search on it, which mean I will pick this high. I'm gonna move it here. So if it if left number is less than okay, maybe I shouldn't do this until we see it in code. If the left number, which is this, is it less than the middle number, we're gonna check if the target exists here before I move this, because maybe it is sorted but the target doesn't exist here. So if I'm gonna check if this sorted, if it is sorted, it means it will allow me to know where is the target. So if it was, we are looking for 3 and this was 0 1 2 3, I can check if it target exists here because it's sorted, right? But if it was random, like 0 1 7 8, I can't check if the target exists here. So because I'm gonna check from the right and left, for example 5 and 1, right? I'm gonna say is 3 exist and 5 and 1. It does not make sense, right? Because it's not sorted. But if we check between 1 and 4, it does make sense because it's sorted. Okay, maybe I did confuse you on that part. I don't think I explained it well. Okay, let's reset. So we are doing if the left number is less than the middle number. So our goal is to see if this part is sorted. Let's say yes, it is sorted. What I'm gonna do is we're gonna do check if the target is on left side, right? By doing, for example, here I'm gonna do if 5 less or equal target than 1, so target 3. So I'm gonna take this number and this number, and because they are sorted, I can it will work. It's gonna give me if that number exists. But now you can see that it doesn't make sense, right? Because this number is 1. Because in our example it's not sorted. So but we need to write something in case it was sorted. So in case this was 1 2 3 and then 1 2 3 5, how it's gonna be pivoted here, and then maybe 0 7, or like, okay, maybe 2 3 4 5 and then 0 1. So in this case, if the left number is less than middle number, which gonna be, for example, 2 and 5, I can compare. I know this is sorted, right? The left number 2 is less than number 5, for example here. Let's just say this is our middle, or 4. So it is sorted. Then I can do like if left number is target middle number. So I'm gonna do this condition to check if actually 3 exists here. And why I guarantee this work? Because I know it's sorted. So if the last number is 5 and this is 2, that means this part is sorted. So if the target is there, what I wanna do, I wanna search here, right? I wanna search here so I can look for its index. So I need to move this to here. Now, by the way, we're working this array. Just to give the example, when the left is sorted, then we can go to the other example. So I will move, for example, our middle was here. I'm gonna move this to here. Or if our middle was here, just example, we're gonna move this here. So we search here. If the left, then we're gonna move middle. So we're gonna move the right. Move the right to middle, right, like just to right equal mid minus 1. So middle is here, so I have the index of this number. If I did -1, I'm gonna end up here. So I'm gonna move right to middle -1, which is this number. Now there's other case where else. What that mean? That mean that this is sorted, but 3 is not here. For example, our targets, let's say our target is 9, and we were like, is 9 between 2 and 5? No. Okay, then immediately we understand it is on the other side, right? So what we're gonna do is we're gonna move this time the low to middle +1. So else the low gonna be middle +1. Okay, so all this started when we said that we did first check that the left number is less than, so we did, for example, left number is less than the middle. So that give us which part is sorted. In this case, we understand the left is sorted. But what if the left wasn't sorted like this? Let's go back to this example. Okay, I think we can remove this. What if the left side is not sorted like in this way? Now, if the left number, which is 5, is less than middle number, we're gonna do this. But else, which mean the left number is not less than 5. So automatically we understand that we're gonna look in the right side, right? Because we wanna look on the sorted array first. So we're gonna write the same code as we did here, but this time we're gonna go and do, so we are looking here, but before we look here, we wanna say, is the number we're looking for, which is 3, is it between 1 and 4? Right? Because if it wasn't, we're gonna save trouble by looking here, because we know this is sorted, and if it's sorted, then I can take the first number and the last number, which is 1 and 4, and just do this equation and put the target here, and if it is false, it means it's not here. Then I cut off this array and they jump immediately to this part of array and start searching. Okay, let's go back. So we said that left number is not less than middle, which in this case, so it means we are gonna search here. Now before I move this to here to start searching, I want to make sure it exists here, so we're gonna do the same condition that we did. If the target exists here, so we're gonna do if inside the else, we're gonna do if the middle number less or equal the target, and less than the high number or like right number. Wait, is it equal? Probably not equal, right? Because we did check the middle. We don't need to check it again, but probably it can be equal to right number, right? It can be 4. So if we are looking for 4, I'm sure it's not the middle because we did check the middle here, check if the middle is equal target. So I'm sure it's gonna be either between these 3 numbers. So check if the target is between the middle number, right, and if it is the right number, the far right number, which is this pointer right here. Okay, if it is here, what I'm gonna do? I need to move this pointer to start search for it, right? I need to find it because I need its index. So we're gonna do the same here. We move the low, so the low gonna be what? Mid plus 1. Let's call them lifts. Lift, and this is mid. 41. Holy. So else, what that mean? Else it mean that like, hey, I did check the left number less than middle number. I understand this is not sorted, so I'm gonna go check here because this is sorted, and I did check if the number that we're looking for, let's say our target is 9, is it in between is our target 9 is between 1 and 4. I found out that it is not between them, so there is no need to check this. I can just eliminate this and start looking here and hope I found it. So what we're gonna do, if else, we're gonna move the right, so at the beginning it's gonna be here. We're gonna move the right to here. So the right gonna be mid minus 1, right? Because I have the pointer mid. If I did minus 1, I'm gonna end up here, so I'm gonna give it minus 1. Okay, so this way we're gonna keep looking for the 9, for example, and then we're gonna loop, and then we're gonna calculate another middle, and when we're gonna calculate middle, we're gonna check if this number 6 is equal 9. No, it's not equal 9. Let's see, check middle, it's equal 9. If it's equal, the target return index of middle. So let's say we're looking for 6 and this end up here, then I'm just gonna stop everything and return the index of 6. If it is not, I'm gonna check if the left number is less than middle number. Is 5 is less than 6? Yes, it is. What you're gonna do, you're gonna check if the left number is less than the target, or the target is greater than the middle number. It's false. It's gonna be false, right? Wait, if 9 here, yeah, because the middle number is not great from 9, so this is gonna be false, which means we're gonna enter else, which means the left pointer, which is this one, gonna be mid plus 1, so it's gonna jump here plus 1, so middle plus 1, and it's gonna loop again, and we're gonna calculate the middle again, which gonna be here. And we're gonna check if the middle equal target, which is not, so we're not gonna return that. We're gonna enter here, we're gonna see if the left number is less than the middle, or less or equal the middle number. It's gonna be yes, because it's equal. And then if the left number is less than the target, which is 0, less than 9, and the middle number has 0, so it's gonna be false. And what's gonna happen is the left, we're gonna be mid plus 1, so it's gonna move here. And when it's gonna move here, the loop gonna stop, because the loop is gonna keep looping while the left is less than right. And the right is here, left is here, left is bigger, so the loop gonna stop, which means there is no 9 number. Okay, that's the full code. Now let's do it with target tree. So let's do air. So now our target is tree. Let's see if this can work. Let's see if we're gonna find it. Okay, while left and right, okay, here is it. We start the middle, we calculate the middle, it is in 1 is not 3, so we're not gonna return it. We're gonna enter, is the left number, which is here 5, is less or equal to middle number, which is 1. Is this true? No. So we're gonna enter else, we're gonna enter this else, right? So we have this if and else, and we have this if and else, if else. So we're gonna enter this else. This else it have, okay, if the middle number, which is 1, is it less than target, which target is 3, or and as is the target is less than or equal the right number, which is 4. Is it true? Yes, it is true. So we're gonna enter in this loop right here. So we're gonna enter this if, we're gonna do left mid plus 1. So left mid is there, mid plus 1 is here. So basically we know that the target is here, so we ignore this, all this array. We're not gonna bother, we're gonna search in this sign. Now we're gonna loop again, next loop, right? Next loop, we're gonna check if the middle equal target. So we need to add something here. We need to put the middle, because the middle we need to move it, right? We need to move middle between this before we check the middle. The middle is still here from the before loop, the previous loop. So each loop we need to calculate the middle. Now middle, let's just say calculate the new middle. Okay, we calculate the new middle between 2 and 4, between 3 elements. It's end up in 3. We're gonna check if the middle equal target. Yes, it's equal the target. Target is here. Return the index of the middle. Okay, it worked. Please, if you have any question, go ahead. It was a long explanation, but I tried to cover like all cases. So please, if you have any confusion or question, go ahead. If not, we can start coding this and see if it's gonna work. If it's gonna work. Let's see. So how are we gonna code this? So define 3 pointers. Okay, so left. So the left's gonna be pointing on the first element, which index 0, right? So 0. Let me zoom a bit. and the middle gonna be what's gonna be the middle? Maybe the middle is not here until the while loop. Let's define the right. The right gonna be the end of array, so we how we can do the end of the array? So we can do like the length, calculate the length of this array nums. So this gonna give us how many elements it have. So if it have 6 elements, 1 2 3 4 5 6, it's gonna say 6, but the last element in the array of 6 elements have index 5, so we need to do -1. And then while left is less than right, while left less than right, which other way to say it is like this loop gonna keep looping as long as the left doesn't cross the right or the right doesn't cross the left. So if they cross them, I know that the number doesn't exist in the array.
I think you need to move the while into the function.
Yes, you are correct. So while we're gonna check what we said. We said that calculate the new middle. So middle gonna be, so there is 2 ways to calculate middle, right? The easy way is to do left plus right minus split or like divide on 2. Left plus right divide by 2. It will work fine in Python, but in languages like C++ or Java, you probably should do mid equal left plus right minus left divide by 2 to like avoid overflow. Here is a Google Doc that's explain why in details. You can like check it. I hope it's correct one. Yeah, you can check it. It's explain why this is better than the other one. Okay, let's do this one just like as a convention. Even the other one to work fine. And both of them, they give us the middle, so there is no need. It just, if we did minus first, we can avoid overflow. Okay, here's the middle. Now we calculate the new middle. Check the middle equal targets. So if the middle equal targets, how we can do that? So we have the middle number index, and we know we are in array nums. So inside array nums, go to the index mid, which gonna give us the middle number, and I'm gonna calculate or like check if it's equal to the targets. I have targets here, it's integer. So if it's this true, return. So we wanna return this middle number, its index, which is mid, right? Mid. Return mid. Okay. Return the index middle, which is return mid. Now the other parts. Let's remove this. The other part is if the left number is less or equal middle number. How we can do that? If the left number, so we have left, which have the index of left, nums left. So we have the left number here, less or equal the middle number, so it is the same one. Okay, if it was like this, what I'm gonna do? I'm gonna do another elif inside. Okay, if again left number less or equal target and middle number. Okay, I'm gonna move right equal mid minus 1 if it is true, else if left else do left mid plus 1. Okay, and else here, which means this is not correct, which means the left side is not sorted, which means the right side is sorted. So then this mean left side sorted, else this mean right side sorted. Else we're gonna do the same if middle number is this the same number, same, it is the same, just we're gonna start from the middle, and here it's gonna be the right. So if the middle number is less than target, and this the target is less or equal to the right number, then left, we're gonna move left mid plus 1, and else we're gonna move it right mid minus 1. If this loop is finished at some point we didn't find it, we're gonna return minus 1.
Yeah, minus 1.
Minus 1. Return minus 1. If this loop find the number, it's gonna return the index of number by the middle target. So if you did understand the pseudocode, you can code it with any language. So if you are new to Python or something, like don't care that much about the code itself. If you understand the pseudocode, you can do it with any language. Now let's hope this can work. Accepted. Nice. Nice. Okay, let's submit. Let's submit. 72. I believe this is same solution we did before. So okay, if someone have question, please code. Yes sir, please. Yes sir, sorry sir, sorry miss, sorry mom. There is the code, coach. Please don't kill me. Python, here I give you also the colors. Python. Okay, if no one have question, please let's jump to the next LeetCode, which I believe Sabah, you want to jump to the stage, explain the host, or like host the rotating orange. Just let me know when you're ready. Or you need a minute?
Give me access to share my screen.
Yes. Okay. Why I didn't fix that yet? Check now. Work.
No.
Okay. Let me see. Video, probably this one.
Yes. No.
Work. Okay. Okay.
Okay, so I'm taking over once again to explain the rotten oranges problem. So you are given M.
Wait, one
yes?
second, please. I think they are still trying to enter your stream. Just enter Sabah stream and then we start. Okay, they are still coming. Okay, we can start.
All right. So we're given an MNX grid, XN grid, where each cell can have one of three values. So either we have an empty cell, or a fresh orange, or a rotten orange. And every minute, any fresh orange that is directionally adjacent to a rotten orange becomes rotten. So we need to return the minimum number of minutes that must elapse until no cells has any fresh oranges. And if that is impossible, we return -1. Okay, so I have these two icons.
Oh.
I was prepared. So 0 means that we have no oranges or we have an empty cell. 1 means that we have a perfectly normal orange. And 2 means we have a rotten
I didn't understand well the problem, to be honest. I didn't understand well the problem. Like what
I'll
do you...
explain it.
Okay.
Okay. So imagine this. Imagine we have a grid, right? All right, now imagine we have an orange here, an orange here, an orange here, one here, and one here, and one here, right? And we have one singular, what's that?
Bad orange?
Yeah, one singular rotten orange. Now this is at time 0, t equals 0, right? So at t equals 0, we have a grid with 1, 2, 3, 4, 5, 6, 7 normal oranges, fresh oranges, and one rotten one, right? So after 1 minute, any orange, let me try something. Any orange that is 4 directionally adjacent to a rotten orange becomes rotten as well. So we scan through the grid. This orange does not touch any rotten orange. This stays fresh. This one stays fresh. This one touches, is adjacent to a rotten orange. So this one now becomes rotten. We keep going. This one again touches a rotten orange or adjacent to a rotten orange. So it becomes rotten again, but we don't count it while we are going through the list. So this one was adjacent to a normal orange, so it stays normal, fresh. This one is adjacent to a rotten orange, and this one doesn't even touch any oranges, so it stays fresh, right? So this is t equals 1, like 1 minute has elapsed. Now, at the second minute, we do the same pass again. This one stays fresh. This one is adjacent to a rotten orange. It becomes rotten. We keep going. This one is adjacent to a rotten orange, becomes rotten. And this one stays fresh at t equals 3. This is the third round. This is adjacent to a rotten orange, becomes rotten, but this one stays fresh. Now, in this scenario, there is no way for this orange to become rotten. So this is what they mean by if this is impossible, return -1. This is a scenario in which we will return -1, right? So the result will equal -1. If we did not have this orange, imagine we had just this grid, the answer would be 3. We would be returning the number of minutes that it took for all the fresh oranges in this grid to turn rotten.
I see.
Does that make sense?
Okay, if one left, or if it at some point they are some of the orange are not rotten, we're gonna return -1.
Yeah, if there's no way for all the fresh oranges, no matter how much time it takes, if there's no way for them, for example, this one will never ever turn rotten because it's not touching any other orange,
Yeah.
rotten or fresh. We shall return -0.
Okay. That's interesting problem.
Yeah. So does anybody have any questions?
Okay.
If not, then does anybody have any idea on where we can start?
Yes, please, if anyone have idea or question, don't be shy. Like open mic, you can talk or write in the chat.
This is similar to the This is similar to the O1 matrix project problem.
Yeah.
So, yeah.
But I already forget it.
You were saying somebody was gonna talk.
Yeah, I was gonna say the first thing we could check for is like if we have an orange that has like no adjacent oranges, we can just return -1 straight away without checking for time.
Oh,
I guess
that's
that's
smart.
the first thing that we could check for.
Okay. So we sweep through the
array
the
or like
grid.
the matrix, yeah, and check if a single orange, like the first instance that we find an orange that has no adjacent oranges around it, we could like straight return -1, and then that would be the first case.
What if we had something like this?
Oh.
This is also a case where it will return -1.
Wait.
You're right.
Wait. What if?
Now it's getting confusing.
What if? Okay, I already lost idea. Never mind. Continue. But that was a smart idea, Abdurrahman.
It was.
Yeah, but I'm guessing we could see that we could check for rotten oranges.
Okay.
Like, instead of, so if a rotten orange, no, it's not gonna work as well because there's multiple cases that we could have.
So this idea is good actually. We check for rotten oranges. We sweep first through the grid and maybe keep the location of the rotten oranges since those are the start points in the grid. Right?
Yeah.
That's where the rottenness starts. Yeah. So we I guess loop through the grid, and that will have actually two functions. First, we check for rotten oranges, and two, we also keep track of fresh oranges. So in the case where the grid already doesn't have any oranges, we can straight away return 0, but also keep it for later count as we turn these fresh oranges into rotten oranges. Once at the end we check if we still have any fresh or not. All right? And how are we gonna check for these rotten oranges? We keep them somewhere?
So is it like this is like a base F algorithm?
Yeah.
Like a queue? We can do like a queue.
Okay. So add to queue. Okay, this is the first half. So we loop through the grid. We append the rotten oranges to the queue, and then we count the number of fresh oranges.
Okay, why we count the number?
So later on, when we keep turning these fresh oranges into rotten oranges, we can decrease the number, and at the end we'll have a count of how many fresh oranges we still have left. If it's in this case, we will have 1. So
if it's not 0, then
so
we
in-
should return 1.
yes. So for example, we remove this one and now we are gonna turn it or like rotten. We're gonna decrease the number of fresh oranges. At the end, we don't have to sweep the grid again to check how many fresh oranges. We already have the count. In this case, at the end, we're gonna check if no fresh oranges are left, then we return the number of minutes. If we have any fresh oranges left, then we return -1.
Okay, I see it
Make
now.
sense?
Yeah. So we're gonna
Okay.
loop on the grid. We're gonna check for rotten oranges. We're gonna add them to the queue and keep increasing the counter of oranges that are fresh. Okay, that's good.
Now, what's the second half of this?
I guess we're gonna loop on the queue. It's like we're gonna loop on the rotten oranges.
Good, and
Now, if a rotten oranges is rotten, which means it will affect its neighbors, right?
yes.
So we need to do that.
So in
like
this
that.
case, let's remove these and have this. This is the first rotten orange encountered, right? So this is the first one that's gonna be added. So I guess
Queue.
rotten orange 1, I guess, to the queue. Right, with the X and Y, the coordinates. Now we're gonna pop it, obviously, and then we're gonna check its neighbors. If it's an empty cell, then we don't have to do anything. If it's a fresh orange, if it's a rotten orange, we still don't do anything about it. But if it's a fresh orange, we must turn it into a rotten orange.
And decrease
Yeah.
the number.
Yes. So,
And we append it to the queue, right? Because it's become rotten, so we need to add it to the queue. So when we loop the next time, it will affect each neighbor too. It's like a virus spreading.
for neighbor and neighbors.
Loop to the queue. Pop queue the rotten orange. And for its neighbor,
So if the neighbor
Is
is a
rotten
fresh
rotten?
orange, we go straight to the fresh orange. So if it's a fresh orange, we do 2 things. We turn
make it
the fresh orange into a rotten orange. And we decrease the number of fresh oranges. Okay, and the third thing is we add the now rotten orange into the queue. Okay, now this should work, right? Except that we're discarding the element of time. Now we're going through the grid, one orange after another, without checking at which time each orange turns rotten.
okay. So each loop in the queue is gonna be time, right?
Not necessarily, no. Each loop in the queue is a singular rotten orange. But we can have multiple ones. We can have 3 in this case.
Wait. Loop through the queue. What does mean loop through the queue? Oh, you're looping through the queue. No, I mean the while.
Yes.
The big one, the while loop.
We don't have a big while loop.
So
We can do that, but that will take too much time to keep checking the grid at each time.
wait. Wait. I think you're misunderstanding. What do you
Okay.
mean
May have a
checking the
sort of
grid
flag
each
for
time?
what,
So when you first start, you go through the grid once. You add the rotten oranges that you have, and you check the number of fresh oranges that you have, right? Then you go through the queue. That is the second step.
Okay, I think
And this
Pacman
is the
said
one
something.
that,
Yes, Pacman, go
Yes?
ahead.
yeah, can we have some sort of flag that tells us if there's any work done to turn a fresh orange into can you not hear me?
A bit
not
low.
a bit low.
Okay, give me a moment.
There was a question. So we return -1 no matter how many fresh orange we have. Yes. So if we end up with, we finish everything and we end up with some fresh rotten, we need to return -1. Can someone take me out from dark? I'm last.
Ooh,
Um,
ooh.
is there like a specific part you're last on? Did you not understand problem or the solution suggestion to it? Just to mention, like what I want to say, Sabah, is like, so the queue, the loop through the queue, is it like when you mean while queue, or when you mean there's another for loop inside the while queue, which gonna loop on a screenshot of the number of the queue? So for example, I'm gonna do a while queue, and then inside it, I'm gonna do for loop that's gonna loop 3 times, because at that time when I entered the while loop, I had 3 rotten oranges. But
Good. That is one solution. Yes.
I have another idea. Can we?
Yes.
I don't know if it's right, but can we actually like pop all of the like rotten oranges, like pop all of them, and then re-add them, and add the ones that we had, like the fresh that turned into rotten, and then count like the T increases by 1, and so on and so forth. Like pop all of the rotten oranges and then increase the time.
That is actually the same idea as Monse. So you pop the current rotten oranges without I mean, I guess keeping the
Oh, yeah,
new
yeah.
rotten oranges. So the old ones. So I guess you loop through the old, like the current, I guess, the current rotten oranges, and it's here where you increase time. So T
Yeah,
was equal
exactly.
1.
Yeah.
Okay, that's an idea. Yes.
mm,
Now,
I think
how do we make sure that? Yes.
I think so like the main loop is the one that's responsible for time.
This one, right?
Okay, I see now.
But how are we gonna make sure that we only go through the current rotten oranges and not the new ones?
Because we're gonna, for example, we can do the length of the queue. If let's say the queue,
Exactly.
like if the length of the queue is 5, then I'm gonna loop 5 times. If I can use the range.
But how are we gonna know that we're going through the like locations of the exact of like the current rotten oranges, like the exact location?
Because
Well,
we
when
add
we
them.
add the queue, you add the coordinates, yeah.
So if you have something in the
I
queue,
think what we can give it,
can you repeat?
like I said, what we can do, like whenever we encounter a fresh orange, and we change it to a rotten orange, what we can do is to change it to another different number that is something like 3. You get?
I'm confused. Can you repeat that? Like
Okay.
when we change the rotten.
Okay.
Oh, you mean the
Yes, well,
from two to one, from 1 to 2.
yes,
So he said
yes.
maybe change it to 3, but how would that affect the rest of the code?
Okay, but wait, let's define the problem. What was the problem? Problem was how we're gonna calculate the minutes, right?
Yes.
And
Yes.
what
And
was the
to
suggested
separate
solution?
the current rotten oranges from the new ones being added. This is one way to do it, and I guess somebody was saying another. So you changed it to +1. Yes.
If we in the first, we can first loop through the array, get, like you said before, get the number of fresh orange. So we know if we get them all, we can know each one will take a minute. If we didn't get them all, then we know we can return -1. But in the first queue, when we get through the array, we can initialize the queue with the number of rotten orange. So with the coordinate of rotten orange. I think this was your idea. The first one. I think it got lost a bit.
Yeah, it's still here. You start with the length of the current queue, and when that ends, you know that the current rotten oranges have all been visited, and then you add time.
I think the idea of more bytes also can work, right? If we change them to 3, for example, we give it number 3.
Yes. But then we should change it also here somehow.
Yeah, we need to check. Okay, someone said, can someone take me out of dark? I'm lost.
So every rotten tree we visit, or we change it, we change its number, but we already have the coordinate. So why we're doing this?
Okay.
I guess to separate the new ones from the old one.
Sabah, you wanna explain to Oduak? Like
I'm
what we're
not
doing?
sure which part they're not understanding.
Okay, Oduak, is it the problem?
Is it
the problem or the solution suggested for it?
Sorry, I also want to add to what is happening right now, because I can see that we have about 3 loops, and 2 loops within a single loop. This is going to be a more than an n time complexity, like it's going to be like n square or something like that. So I don't know if we can be able to make it more faster. I don't know.
I'm not
Maybe
sure
we can
it's gonna
increase
be on square actually.
time complexity.
Because okay. I still don't think it's gonna be on square.
Okay.
But please tell us which part you're not understanding.
Okay, maybe she's AFK or can continue. Or if she's talking, we can't hear you if you're talking. Okay, so now.
So yes, there's this way to, I guess, keep track. So when you loop through only the first rotten oranges, and after you're done with this, and now you have, for example, these 2 new ones, in your queue you'll have only these 2, right? Your new queue at the end of this loop, right? So let's write that actually. So in round, I guess in t equals 0, q is gonna equal, I guess, 2, 2. Which ones did we have first actually? Oh boy. So we had okay, so we had we had a t equals 0, we had q, we had 2,
Okay,
no, 1, 2.
Or do I write something in chat? You wanna address it? So she said she doesn't understand the part where we turned fresh orange into the rotten orange.
Okay,
Why we do that?
so, all right, so now each fresh orange that is adjacent to a rotten orange becomes rotten, right? So 3 things happen when we turn this fresh orange into a rotten orange. First, we I guess change its number from 1 to 2, right? And then now we have 1 less fresh orange in our grid. So we decrease the number of fresh oranges, and now this is a rotten orange, and Q is I guess a queue that holds rotten oranges in our grid. So we add this new rotten orange into our queue so it can turn its adjacent rotten orange, fresh oranges. Say, for example, I guess we had a fresh orange here, right? Now this, after being turned into a rotten orange, also needs to turn its adjacent fresh oranges into rotten oranges. So this one also becomes rotten, right? We won't be able to do that if we didn't add this to the queue. I hope that cleared it up a little bit.
Yeah, I think I get what you are trying to do, right? Can I please go back to the screen? Okay, so actually I just actually got it now from where you said like this for neighbor in neighbors. So therefore what you're doing is like when you check for a rotten orange and an orange and a rotten orange, and you change the adjacent good orange into rotten orange, we add those rotten oranges to a queue. So the next time we are coming, we are not going to search through any other thing but the queue, right?
Yes,
Like the queue,
exactly.
yeah. So we are going to be using the queue to change other good oranges to rotten orange and adjacent to it.
Yeah. I mean, you can put this entire thing into a loop, but that will take too long. So to cut on this part, you add these new rotten ones into the queue again.
So you only
All right,
check
makes sense?
the rotten one instead of looping all
Yes.
again.
Exactly, yes. So we can go with this idea of checking the length first before looping through the current oranges. So if in this case we have, let's complete this idea. And then we had 2, 2. And let's imagine these are current rotten oranges, right? So after the queue passes to here, it's gonna add 2 more. It's gonna add 2. These are new, right? These are not part of the old set. This is the new set. I guess I can do it this way. This is part of a new set of new rotten oranges, right? It's gonna be this one and this one. So this is 2, 3, and then 3, 2. But we don't want to loop through these. We don't want to count these in the iteration, right? We want to separate these as the first minute and these in a second minute, right? So we hold as he said, like a screenshot of this queue in here, right? In a length of this current queue. Once we get to this length, we stop, we update the time, and then we can move on with the rest of our queue. We'll keep doing that until either we have no more rotten oranges to check, or we have no fresh oranges in our queue, in our grid.
Okay. So what we can do? Yeah, it makes sense. Made a lot of sense. So what we can do is instead of using a different queue, so whichever rotten orange we encounter, we pop it out queue so that we don't have to go back to it in the next iteration. Then in the
Exactly.
next, yeah.
Yeah. There is another way to do it, and it's basically just like levels of propagation, where instead of adding just the coordinates, you also add a level, I guess, or a time, and you keep adding one to it, and the last one to be popped will have the maximum time. That's just an idea. We can see about it later, but for now, this should work, right? We loop through the current rotten oranges, and we pop. We go through the neighbors. If the neighbor is a rotten orange, is a fresh orange, we turn it into a rotten. We decrease the number of fresh oranges, and we add this new rotten orange into the queue. And at the end, we check if there are still fresh oranges in the grid. Then we know that there's no possibility for that orange to ever turn rotten. And in that case, we return -1, or else we return our T that we have updated here. Any questions?
Network. I think this is a BFS, right? The algorithm.
Yeah, it's
Yeah.
BFS.
I think you should have stated it to have our mind in BFS. Right, thank you.
I think most of us said it earlier.
Yeah. Okay, I wasn't fully focused. I was writing in chat. Okay. Let me see if I understand. So we pop it, we check the neighbor. If the neighbor is fresh orange, we turn it to a rotten, decrease the number, add the new rotten into the queue, and at some point the loop through the queue, or like maybe if we write while, so the loop through the queue is like while, it's gonna be the while loop, right?
Yes.
If there are still fresh orange in the grid, return -1. If it's case, okay. I think it's clear. Someone might not understand how the queue work. So I did like a picture in the chat. So like we, you can show it like if you want. Like we add like the red one, and then the new one are like the blue. While we are like, treating the red one. So we add the red one, we add the 2, 3. Now this is the first minute. And then we treat them, we pop them, we treat them. And while we pop them, we might add more to the queue. And those are like a different color because we're gonna treat them in the next minute. Right, Sabah? Is that...
Yes. Exactly, yes.
Okay, we can... Anyone have question? We can continue.
So is that why we needed the length? Because we are adding more and more elements to the queue, right? Because we can't have the
Exactly,
condition
yes.
that if the queue has elements, then go on through the while loop. That's why it's not going to work, because we keep adding more and more elements. I think
Exactly.
that clears it out.
So we need to
Yeah, yeah.
separate the first element from the new element.
Yeah.
So, yeah, in
This
addition,
could be important. Yes?
I think instead of us using that length, can't we just use the time instead and add it to the list, like to the queue? Like we append it
Exactly.
to coordinates, right? And let the time be the last the last number in the coordinate. I don't get. I don't know if you understand what I'm trying to say.
Yeah, we can visit this idea after we put this into code because it's pretty easy. It's also it also increments the time, but does it this way. So, for example, let's put this here. It's almost like levels. So at level 0, we have this. At level 1, we have this. At level 2, we have this. So it's almost like each orange carries its level. So at the time it was added to the queue. So at time 0, these new, or these like the only rotten oranges in the grid were added at time 0, right? These oranges are gonna get added to the queue at this time +1, right? So this one was added not at 0, not at 1, but at 2, right? So we keep incrementing the time, but it's inside the queue, so it's almost like this. T. So in this case, it's going to be 0. This one is going to be 0. But this one is going to be 1 because it was added at 0 + 1, which was 1. And any other, we just keep incrementing. We can do this after, maybe. But this is, I guess. Okay. Do we turn this into code?
Yeah, let's do the magic.
Okay. All right. So we initialize a queue, just the queue without importing, and we loop through the grid. So we can have an m equals len of grid, and then n equals len of, so these are m and n, right? Now in looping through the grid, so for xn range m, y in range n, so we check for rotten oranges. So if grid x, y, so rotten oranges is a 2, so if it is equals to 2, then we append it to our queue. So queue.append xy, right? And we count the number of fresh oranges. So we initialize a fresh counter to 0 that we keep incrementing if we have a fresh orange. So if, I guess the left, equals 1, then we increment our fresh counter. So far so good?
I believe so. Any question? So what this part is doing is just looping through the first time array and adding the rotten to the queue and counting how many not rotten or fresh we have, right?
Yes. So we populate the queue with rotten oranges and we count the number of fresh oranges.
Okay.
So now we loop through the queue. So while queue and fresh, so both while queue is still full and fresh doesn't equal 0, right? We increment the time. So this is a new time. We must initialize it outside. So now t, which is the number of minutes elapsed, it's getting incremented, right? we calculate the number of the current oranges in the queue. So rotten, we call it rotten, equals the number of rotten oranges in the queue. So we can loop through only these oranges, no matter how many others we add to the queue, right? So for, I guess, orange. So
Or underscore, maybe, in a range of the length.
and range rotten. Okay. So we pop Q. Yes?
I was just gonna say, like, if someone didn't understand what that means, so basically that's gonna loop. So if the length of rotten was 3, which means like in the queue there's 3 rotten, that's for loop, it's gonna loop 3 times. That's all.
So
You
now we
pop it?
we call it, I guess, current X, current Y equals pop. That's, I don't know.
Pop left.
Left. Now we have the coordinates of our rotten orange.
Okay.
And we must now look through the neighbors. We can either do the directions 1, 0. So these basically just look through the 4 directions of the orange, right? It looks through the left, which is +1, looks through the right, or the right +1, the left -1, up, which is
Row.
-1, and down, which is +1. Yeah, so I guess row -1, row +1, column +1, column -1, which is basically this. Now, for, I guess, dx, which is the x of the direction, and dy and directions, we add these directions to our current rotten orange coordinates. So we can either go up, down, left, right. So qx x plus equal.
So what we're trying to do here is to check the neighbors.
Exactly. So we want to go through the 4 neighbors of that rotten orange, see if they can be turned into rotten oranges. All right, now we have the coordinates of the neighbors. We're gonna check if they're valid, because, for example, rotten can be here. We cannot check on the left. Rotten can be here. We cannot check on the left or down. So if 0 is smaller or equal than qx, which is smaller than the m, the length of the grid, and 0 is smaller or equal than qy, it's going to be smaller than number of rows, the columns, right? And then we're going to check, I guess.
If it is
Then we're
fresh. If it
Yeah.
is fresh.
We're going to check if grid ux uy is a fresh orange, which means it's equal to 1.
I think
Now, 3
missing
things we're going to do.
end before grid.
Oh, yeah. Right. So we're going to turn this fresh orange into a rotten one. So going to be equal to now, right? We decrease the number of fresh oranges. So fresh minus equal 1. And we add these new coordinates to the queue. So q dot append q x q y, right? Now this is gonna keep looping as long as, well, I guess it's gonna loop through the oranges, but as long as the queue is still full and fresh, as in like we still have fresh oranges in our grid, right? If one of these becomes false at any point, it stops the loop, and that's when we come here. If it popped, if the while loop stopped because we have no more rotten oranges to, I guess, to turn. So in this case, for example, we have this and this, and these rotten oranges have not any fresh oranges around them to change. So at the end of this scenario, the queue is going to be empty while fresh still equals 1, right? If we had removed this, so the loop is going to end with no more fresh oranges, and the queue is going to be empty, right? And the fresh oranges may become 0 before the queue becomes empty, right? Imagine like we just have random rotten oranges around, right? So it doesn't matter because we have no more fresh oranges to turn. So there's no point in looping through the rotten oranges. So we check if fresh. So if fresh means we still have fresh oranges in our grid, we return -1. Else, we return our t.
Wait, can you repeat that?
If we have any more fresh oranges left in our grid, even after Q is empty, then these fresh oranges cannot be turned into rotten. So we return -1. Else, we return the t that we kept incrementing here. Any questions before I run this?
Any question, guys? Please don't be shy.
Yes. So I have a small question.
Yes.
There's this if statement that you had, if 0 is less than or equal to q of x less than of m. Are we checking here that it's inbound, like it's not out of bounds of the array? Oh, okay.
Yes,
okay,
exactly. So we check if q is bigger than 0 and is smaller than the length. So we check if this coordinates does not fall below 0 and does not fall above the length of the row, right? And then we check if it falls below 0 and above the length of the column.
Awesome. Thank you, Sabah.
Oh, nice. Nice. Let's submit.
Oh.
So one case. What will be?
Okay.
1 and
so
2.
1, 2.
It's maybe some each case.
So 1, 2 means what?
Minute. Go up. What you did in the default value in the minute? Do we start with 0?
Yeah.
And
so it is a grid of 2 where we have 1 fresh and 1 rotten, and it returned.
Can you remove that and fresh? Just random. Like
Where, here?
Yeah.
Okay.
I have no explanation. Just random. No.
Yeah.
We can debug it and
So
see where it's coming from.
Yeah.
It's fun.
I think it comes from where we have, can you go now a little bit, where we have if fresh, almost the last part of the
This one?
code. Yeah, if fresh.
Maybe.
So like for the first iteration, this code is going to, this test case is going to end in the first iteration. And at that time, our value for fresh is still, I think it's still 1 as at that time.
But we need
when
to,
you're returning this map.
but like,
I don't think I understand. Can you repeat?
can you pitch more, bro?
Okay, can we, okay, I said in the first iteration, I think that the number of fresh oranges that we have, I think it is still 1 in that first iterations. But maybe we can run a pseudocode for it, or a drawing, so I can be able to debug the issue.
Print.
Print fresh is the one.
Also behind the return, like after the while finish, print the.
In this case, we have
Okay,
1 fresh.
like, can you
So
print
at
it
the end,
before? Yeah. Like after the finish of the loop.
Oh, so it didn't decrement it.
No, I think print it after the end of the loop. Yeah, move it a little bit leftward.
I'm not understanding, I'm sorry.
Like the printing flash that you did just now is inside the loop. Move it out of the loop.
Oh, okay. Like
If it's out of the loop,
like yeah, there.
yeah,
Exactly.
it's still gonna be 1, I'm pretty sure. Since at the end of this, it didn't decrement it.
Okay, can you
So did it?
can you remove the test, or like, or can you
Yes?
maybe paste the code in the chat?
Oh, okay.
And like, let debug see.
What about
Someone said,
directions?
yeah, someone said direction. Let's see. If someone wanna help us debugging this, then we can see where the problem come from.
I think
There's
maybe
the-
we're changing these. No, that shouldn't matter. Okay, so does it enter here? It does. 4 times. Does it enter here? It does not. Why is that? UX.
The weird thing about it, if you actually make it 2-1 in the grid, it passes. But 1-2 doesn't pass.
Does.
So if in the test case, if you change the grid to 2-1, it actually passes. But 1-2 doesn't pass. So I don't know what's wrong.
So it doesn't even enter this There's
Yeah.
something maybe wrong with this?
Yeah. Something wrong in this condition. Or maybe not in this, maybe in the direction, in the way you have QX and QY. Maybe it's you need to change their name or something because they're up when you change it up and down. I don't know. Just
Okay, we can try that. UY plus dy. And then new x, new y, new x. Let's see. Yeah, you're right.
Oh,
That was it.
what was the
No,
problem?
why? So I was
Nice.
changing it to these. I was overriding QX, but I'm unsure why that matters. Oh yeah, because oh my god, with the iteration I keep, yeah, that makes sense.
Oh,
Okay.
the for,
So
we need to
with
save
each
the value.
iteration I keep adding to this QX.
Okay.
That was not smart. But yeah, okay.
Okay, that's nice.
Good one, man.
Nice. Submit again, maybe it will be increase. Nice work, guys. Nice Sabah. Nice work, everyone.
That's even worse. Okay, there's the other solution that we discussed earlier,
Yeah, how
which is
that will be?
adding a 0 here. Add a 0 here, so the Q has both X and Y, and the time it was added to the Q, right? Now, there will be no need for this loop, right? And even this will not be here. Let's see if I can do this. So T will be here, and we do the same, except here we do T plus 1. And here we take it. Yeah. And here we keep T as the max of, I guess, time as the max of the current T and the overall T time. So we, I guess, have time here. See if this works actually.
Line 14.
14. Yes.
Let's do meditation.
That did not work. Why is that? I guess time, that's one? No.
Okay.
Interesting.
Wait, go back. So we append them with the 0, then
Yes.
we have time 0, we loop, and then we pop, and we pop. So we're gonna pop all the elements, right?
I think we're not supposed to append. Okay, sorry. No.
Where we do increment the thing when we append. So when we're gonna append, we do T plus 1. Refresh.
It's interesting.
Are we supposed to check the maximum time?
I mean, I did it here.
Okay, why we did it there? Time, max T, and time.
So I guess it just, maybe we put it before.
But why? Why we wanna
Here?
do that? Why we need time?
So we just want to take the maximum time between the one that we already have, right, and the current one. So this is the current number of iterations, right? And this is the number of iterations relative to this coordinate.
So 25 should be time plus 1, not t plus 1.
Time plus 1?
Yeah, time plus 1.
I'm still a bit confused about this way. So we append them with t, and then we enter the loop queue and we pop the element and we say, okay, let's do the time now. It's gonna become the max between t and time. But
Yeah.
why? Oh, so because I want to keep counting the time for each level. So
Yeah.
at the first I'm gonna level 0 or 1. What level we are? 0 or 1?
No, we're gonna be in level 1.
So the one that I'm gonna append at first, they should have value 1 or 0.
So these ones should have value 0. And their neighbors should have value 0 plus 1.
Yeah, I also think we are supposed to increase the time. Yeah, we're supposed to increase the time before we check the maximum time. Or yeah,
We
I think
increase
so.
the time? Well, I had this before, it didn't change it. But
Okay. Wait, can you like reduce the test results just to like see the whole code?
okay.
Okay, so let's maybe check it like a simulation in our mind. So we loop through, we put all we put them all, append them with 0, and then we have the time 1, and we while queue we keep popping them, and we go to their neighbors and we make them rotten. We reduce fresh -1, and we append the new rotten with the value that they had before. We increase it, and then we go to the time and we do max time. So time was before 1, and now the max gonna be t, and t was 0, so it's gonna be 1. Okay, and the next loop we're gonna pop the t plus 1, and so the max time gonna be 1 1 1, and the next time it's gonna be 2. So time is time gonna start from 0 or from 1?
It should start from 1.
Okay.
But
And then,
it will keep changing as we go along. So technically it doesn't matter.
okay, but in this way time gonna be always 1, so we're gonna return no
Should be 0.
wait, is there a case where we're gonna return time 0?
Yes. If there are no fresh oranges.
Okay, so let's test if it's time 0 gonna do any difference.
I had that. So the issue is the output is 3, the expected is 4.
Okay, what if we did time plus 1? Or like,
Yeah. That would be okay.
I mean, because it's like we're missing 1. Okay. So there's some edge cases. I see.
Yeah, the rotten orange.
Hmm.
I think we're not truly finding the problem. There's a problem there that we need to find out. There's a bug inside the code.
Okay.
Now,
So let's try.
okay. Now when
So I
we
think
think
line
about it, it should work, right? Because at
Yeah, it
the
should work
end,
too.
because at the end, I'm gonna have time variable that have the maximum number of the t that I keep popping, which mean I have the number of the loops. So where could be the problem? We can take one of these cases and like take it to Excalibur and like loop through it and see how it's gonna.
Yes, we can.
You wanna like maybe copy the code in chat? Minatala, where are you? Where are you? Fendi's back.
Where are you when we need you? It'd be smart to return T, but time would be the max, so it makes sense.
I still think that line 24 should be time, not instead of t.
But like we wanna increase the t, right?
Yeah.
Because when we pop the elements, we are in level 1, for example. So when we're gonna append them next level, we're gonna increase that level by 1.
Well, they may not be in order. We might get to, for example, this one before we get to the one in a lower level, maybe.
Yeah, but like they all have the same t because we append them in the same time. Right?
But what I'm thinking is like you know that sometimes you might have like some of them that have time 0 and some of them that have time 2, right?
No,
So
no,
let's say for
that's
example,
not possible. That's not possible because when we append them, because when we append them first time, we give them always 0, 0, 0, and then when we loop the second time, we give them all 1, 1, 1, and because we loop on each group each time, so we will never have mix 1. Or I am missing something.
But like it is not like there are cases whereby you know you're looking from as you're popping a number, you're adding a number, you're appending another number to that particular queue. So you don't know the particular data you're actually working on at that particular time.
Maybe I'm misunderstanding. Okay.
Yeah.
Okay, there is a 10 here. Now, this one that I'm gonna append, it means I found it not rotten, right? So it is fresh. So it is the first time it's gonna go to the queue, right? So if it is the first time it's gonna go to queue, it should be, it's like I'm gonna add it to the next phase, right? So I need to know what phase I am. Is it phase 2, phase 3? And then we can increase that number. And the number of the phase is the number of t, right? Because at the start I am in phase 0. That's why all the queue, that's the element that's added in the phase 0, gonna have t0. But all the
Then there's no need for this.
okay, remove it, I guess. I don't know. I think. But how are we gonna return the time?
It's gonna be the last. Okay, that makes sense. It could be the last thing that's popped in the.
We just need to. There's just small thing here that doesn't make sense.
Okay.
But did you get
I
me more
think,
about the T+1?
Yeah, but I think I also have an idea right now. I don't know if it's going to work, but maybe we can. Can we go back to that line 14, change it back to time? The line
We
14.
remove time.
Yeah, like let's go back to what we were doing before when it was time. And then instead of I was talking about, then this instead of us having time plus 1, why not increment time? Like its value itself, because here we're not incrementing time.
Let's so increment it here.
Yeah, like you don't like here we're working with the maximum time, but the time was not okay. Okay.
Also, this maybe should not.
No, it should be there. But I was thinking of yeah, it should be there now. Fresh should be there.
Fix this.
Okay, wait. Wait, go back to the now if we're looping, we have time. So what the point from the time? We wanna increase it, right?
Exactly, that's. But we already increase it here.
But like a time, it will make sense if we use t, not time.
It makes
Because
sense if we remove time entirely. Since the last element to be popped will be the one at the last level,
yeah.
right?
Okay, let's remove time and just access the last element.
Yeah, exactly.
So we're gonna access the queue, or we're gonna access.
We keep fresh.
Okay. So time was 0, then
I
time.
tried that.
Okay, can you print time at the end?
Here?
Oh, it's pass. Nice.
So removing fresh from here. Why?
Because we still need to
So I
loop,
guess
maybe? We still need to loop on others, so it increase the time. So maybe our time is missing 1. Maybe we should start by 1. Let's try 1. Maybe even the append should be 1. I'm not sure.
No, the append
I
should be
don't think
0.
you should start with 1. 1 give you when it's 0, like there is no fresh. So anything, if you return, it will return 1, not 0. You need to return 0.
Exactly. Why did the fresh?
Okay. If we did fresh, that means there is something still in the loop, but the fresh are there's no more fresh, which doesn't make sense.
Oh, the queue had all.
I think because when you bob left T, when you remove fresh, you bob left T. It bobs the final element, the final element in T. But because you add T+1 in the queue to append, T+1, it doesn't add. If you actually return T, it returns the last value, not the value plus 1. You added in the bob left.
I guess it would make sense to see this one since it's so short.
Yeah, but
So
like you can you either add fresh or you add the time, one of the two, because you need bob left in the T if you have it to give you the last value.
You're right. You're right.
Can you explain
So
to me?
now the queue has this element,
Mhm.
which is the one that's gonna update our time, but it doesn't get popped because, yeah, you're right. You're right. We need to pop this
Oh,
to update the
before.
time.
Okay.
Yeah.
So we're relying
That
on the
makes
poppiness. Very smart.
Exactly, yeah.
Minatala.
As always.
Let's clap for Minatala again for fending the back.
Thank you for clapping me while Sabah was actually explaining for an hour and a half.
We clap for both of you. It's like a teamwork.
Okay. Yes. Okay, it's faster though
Nice.
than our.
Nice.
Okay,
Nice.
still there's something wrong in your network connection because I ran it. It's 96%.
Wow.
Your code, by the way, it's 96% at my end.
It's
going worse.
been worse. Okay. Oh,
Like I
at
ran
least
both
it
your
works.
code and both time it was faster for me.
Okay.
Okay,
There's
so it
something
ran
wrong
better
with
on my
my
machine.
laptop. Okay.
You,
Yeah.
you can show this this calendar. It's like to see the next session.
week's.
Okay, you can click in month and the day, like above.
Oh.
No, right side, month. Okay, so maybe you should hide. Okay, so the next session gonna be on 27. Right. Click on the PLD 33. PLD 33. Right down that one. So we're gonna have combination sum and permutation. What the hell is that? And if someone I will link the planning of the next week if someone like wanna do. I write it in chat if you wanna show it, Sabah. If someone wanna like do or host some of this LeetCode, please let me know. Like just go and present it. Maybe show your solution or like explain to us, like Sabah did or Minatalla before, or Muhammad Isa. That's it for tonight. Hope you guys. Yeah, this is the week 9, which is next week. So that's it. I hope you guys have a good night, and yeah, see you next week.